Now our topic is Kepler's law, Newton's universal law of gravitation. Now come to the Kepler's law. Now planetary motion had been observed by astronomers since before 16th century. Now Galileo, all the observation of a planet's positions were made with the naked eyes. Now many scientists are collected the a lot of data were available about the planetary position and the motions. Now Kepler he studied the this data and he noticed that the motion of a planet follows certain rule, certain regulation. So that he stated the some laws. So that is known as what? Kepler's laws. Now first we are going to study Kepler's first law. For the study of Kepler's first law, first we try to understood. First, an ellipse is the curve obtained when a cone is cut by an inclined plane. That means what? If we take the cone and if we cut that cone in the inclined plane, so we will get the whatever a part that is known as a ellipse, and that ellipse have the two focal points. Now come to the Kepler's first law. So Kepler he stated the law. So what is the law of Kepler's first law? The orbit of a planet is an ellipse with the sun at the one of the foci. That means what? If we consider S is the denoted as the what? Sun, and this part is a what? Orbit of a planet. So this part what I am showing in the diagram, that is a part of a what? Orbit of a planet. So first law of according the Kepler's, the orbit of a planet is an ellipse with the sun at the one of the foci. That means sun is the one, this is the center, and this is a what is known as the orbit of a planet. Now here come to the second law. According the Kepler's second law, the line joining the planet and the sun shifts equal areas in equal intervals of time. Now if we see this is the S, if we see this is the point A is a position of a planet, and this is the what? Time, that is the distance. So what he said, the area of this part, whatever the area of a triangle ASB and the area of a triangle CSD and the area of a triangle EFS, all these three areas are equal. So we have to say this area triangle SAB, area of a triangle CSD and the area of a triangle EFS is equal. Now come to the Kepler's third law. So what is the Kepler's third law? The square of is the period of a revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. Now r is the what? Average distance of a planet from the sun, and the t is a period of a revolution. So if we see, so this is a known as a what? Period of a revolution. This part is a known as a what? Period of a revolution, that is a denoted by t. Now we consider here, this is the r1, this is the r2, this is the r3, this is the r4, this one r5, and this one is the r6. Here is a given the mean of a r, that is we have to take the average. So r is equal to what? R1 plus R2 plus R3 plus R4 plus R5 plus R6. That means we have to take the mean. So here see here, this one is a what? Here given t square, and this is the sign of a proportionality, that is a r cube. That means t square upon r cube is equal to constant, that is a k value. That is a what? Equation number 1. So we have to say t square, that is a what? Square of the period of a revolution around the sun is directly proportional to the cube of the mean distance of planet from the sun. So Kepler obtains these laws simply from the study of the position of the planets by the regular observation, but he don't know any explanation part why planets obeys these laws. So this is regarding the what? Kepler's law. Now come to the next topic, that is a Newton's universal law of gravitation. Now if we consider this is the object A, this one is the object B. So this is the mass of object A, m1, this is the mass of m2, and these two objects having the some force. So here is a force directed and here is a force is directed. Now distance between two objects is we have to write the d. So gravitational force between the two objects. Now the scientist Sir Isaac Newton given the some law, that is he given the some law, that is known as what? Newton's universal law of gravitation. Now here every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of the two objects and is inversely proportional to square of distance between them. Now if we consider the two objects, that is object A and this is known as object A, this is object B, this is the mass m1, this one is the mass m2, distance between them is d. So we have to say f, this is the sign of a proportionality sign. You know very well what is the proportionality sign. F proportional to the m1 into m2 divided by d square, or we have to write f is equal to g m1 m2 upon d square. This is the equation number 2. And what is a g? G is known as a constant of proportionality, and it is called the universal gravitational constant. It is known as a universal gravitational constant. And the mass of any object is double. The force between two objects also doubles. Now if the distance is double, the force necessary by a factor of 4. Now the SI unit of universal constant, that is G is Newton meter square kg raised to minus 2. And what is the value of a G? That is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Thank you very much.